Hello everyone. Is my voice audible? Yeah, fine. Let us start the assignment for week 3 of the previous course. Like, just let's clarify what this week 3 here is. This is not this year's. This is just for the previous year's assignments for week 3. So don't think that the whatever I am solving here is for this year's coursework. Okay. So fine. Let's start from the first question. The first question is pretty simple here. The first question says the eigenspectrum density of a signal is real. And you have to comment whether it is true or it is false. Anyone here in the chat box commenting about it? Okay. So this is sorry, this should be just a modification. I did it wrong. This is energy spectrum density. Forgot. We used to use the term eigenvalue. So this is whether energy spectrum density of a signal is real or it can be imaginary or it can be complex. That you have to make a comment. So basically, this is the energy spectrum density, right? And energy of a signal. So basically, what does means? Plot the energy in the y-axis, and in the x-axis, you just this is the frequency. So basically, this says what is the energy quantity in the particularly that spectral density. What is the energy spectral density in that case? Basically, energy is a real quantity. This concludes the fact that the energy spectral density, that is the ESD, will use this abbreviation later also. This ESD is a real quantity. For a signal it is real. So always it is real. So it was pretty simple question. I think there is no doubt about this question for anyone here. Right, fine. Question number 2. Question number 2 says if the energy spectrum density of a purely imaginary signal is not event symmetric. And you have to comment whether it's true or else this is false. Comment in the chat box. For this question it is B or it is yes. Sir, it's for this question, right? Yeah. So actually the answer of this question, ESD, is the eigenspectrum density of a purely imaginary signal. It's not even symmetric. That is false. So let us say why it is false. First of all, we are talking about eigenspectrum density. Sorry, again. Yes. So let's write ESD here. So what is that ESD particular? We have a signal xt, and if I do a Fourier transformation here, I will get a frequency domain representation of the signal xt, that is xf. Xf is the Fourier transformation of that xt. So now what will be the ESD of that signal? Basically, if I want to get the ESD of the signal, this is about the energy of the signal in the frequency domain. So how do I quantify that? Basically, this thing is xf, that is the frequency domain representation of that signal. Like xt has a time domain representation and it will have a consequent frequency domain representation. If I think about energy, that is mod of xf square. That is a Parseval's relationship, that is xt mod of xf square within the range of the signal. It's actually equivalent. So always remember, basically if this quantity somehow represents energy, this quantity also somehow represents the energy. So these two are mode of equivalent. Integration is term of dt and this is about df. However, this two term quantifies the energy. So now basically what is this big xf mod square? That is actually use of f the complex conjugate of that particular signal x star f, right? So similarly, if I take a signal x First I had taken xt, now I have taken x conjugate t, and it will have frequency domain representation. This. If this is a purely imaginary signal, so what would happen if it was a real signal? If it was a real signal, then these two are equivalent. Then we could have said that star of f is equivalent to x of minus f. This is for the real case scenario. And for imaginary case, what does that mean? It's x of t. So this implies star of f is equal to minus x of f minus f. So this is for real case scenario and this is for imaginary. From this relationship, we have concluded the facts. So, till now, what are the conclusions we have reached? That if a signal is real, xt is equal to x star of t, then the relationship in terms of Fourier transformation says that x star of f is equal to x of minus f. Similarly, this is for a signal is real. And for imaginary, it says x of t is equal to minus of x of t, I mean x star of t, if I think. Same relationship, I just want to get here, it becomes x star of f is equal to minus of x of minus f. Just this is the difference. Okay, the star complex conjugate version. That is the star. So basically what happens, if you have a signal x of t that has a real component xr of t plus j, that is the complex part, I of t. What happens if I take a conjugate of that, this signal, this conjugate, it remains the same because this is real, but if this conjugate just changes the sign of the imaginary term. So this is positive for xt, and if I take x star t, then it is negative. But in this question, it is said that in our question, the question was a purely imaginary signal. So purely imaginary signal means that the x of t, this signal has no x of r of t content, because this is purely imaginary. So only term that is here is this complex term. So what happens if I take x star of t, if it is purely imaginary, this is minus j of xit, where xt is equal to j of xit. So basically this person is minus of this person. Okay, so I think this is clear. So basically what we need to check whether the eigenspectrum density is symmetric or not, right? So basically what is eigenspectrum is this, like x of f into x star of f. So for both real and imaginary signals, this is x of minus f and this is minus of x of minus f, right? So if we want to calculate the actual energy spectrum, let's take for this imaginary signal. It was for imaginary signal in our case. So let us derive for this only. It will be easier to understand. So x star of f into x of f, right? This is what energy spectrum density is. So this will be minus x of minus f. And x of f, right? So this signal, whatever this is, it will be symmetric. Okay, I think this is clear. So basically the answer will be false. Not even symmetric, it is even symmetric. Always even symmetric, that we have concluded from this. Because we are taking at least in the end, this is about mod square. That is the main catch here. Okay. Now let us move to the question number 3. Anybody has any question? I think nobody has any question. So just you need to comment the power spectral density can be periodic. This is the question. So whether it is yes, option B is no.
No,
Yeah. basically the reason, let me write it. Say if ESD of a signal is periodic, let us assume first for yes. So this integration will go to infinite for the PSD calculation. But if I think about a power signal, power is always finite. It itself represents that what is the energy of a periodic signal within a particular time period, with which time it is periodic. So itself it should be always finite. But if this integration goes to infinite, then there will be a problem because it should be finite. So that is the reason PSD of a signal is not periodic. Okay. Now let us move to the next question. Next question says the ESD of convolution of two signal is equal to the product of their individual ESDs. And you have to comment whether it is true or it is false. So basically the question means you have a signal x1 of t and another signal x2 of t, and that they have a Fourier transformation of x1 of f and x2 of f. The question says you have to comment this following condition holds or not. The following condition is in the terms of x1 of f into x2 of f square is equal to x1 of f square into x2 of f square. That is the individual ESDs. It is individual ESD and it is the ESD of these two signal x1t into x convolution of that ESD. This is the convolution logo. So You have to comment whether this condition, whatever I have written, is false or true. So from this condition, it is more of, I have already written the answer, like see x1t and x2 of t. So I am doing some convolution here. So if this is a convolution, the frequency domain representation will be multiplication. This is the multiplication. So the question says I have two signal x1 of t and x2 of t. I do their convolution. So basically if I do their convolution in the frequency domain, it will be their multiplication. That is the first part of the question says convolution of two signal. So there is a convolution between them, and this will represent as multiplication of this. Now I have to calculate what is the ESD of this signal, right? So ESD of this signal is x1 of f and x2 of f mod square, and then they are again asking it should be equal to their individual ESD, product of their individual ESD. So this says from this it is x1 of f, and it is the ESD of the first signal and it is the ESD of the second signal. So this equation holds because only this is a norm squared type of thing, and we have taken the absolute value of t. So even if it is complex number, this absolute value will make it a square plus b square if it is a plus ib. So that is the condition. So it is true. You can take any example, whether you can take xf as a complex type of thing or real type of thing or purely imaginary type of thing, whatever you want to take, but there is a absolute value here. This absolute value will always contribute to a particular real value, and this condition holds for only this. But if it is a simple multiplication, like this condition does not hold, like this condition will not hold normally. Is equal to mod of x1 of f, x2 of f. This condition will not hold because we are taking some absolute value type of thing. These two condition holds here. I think this is clear to everyone. So next question is the energy spectral density of a signal SF is a rectangular pulse with the period of this. And we have a signal. This is the time domain representation. So basically written the question wrong. Clear it. have a signal st, that st is not equivalent here. We have a signal s of t, and s of t is a rectangular pulse. This is not pi. This is a rectangular pulse. So the function is written like pi of t by bt. So the question is, we have to calculate the ESD with of the term s of f, that is the Fourier representation of st. And there are four options. First option is bt square sin pi f t. Option B is b square t square sin square pi f t. C is bt square sin square b pi f t, and D is obviously none of these. So just type in the chat box what is the right option it would be. So always try to remember what is the representation of a square pulse in terms of Fourier representation. Like a square pulse or a rectangular pulse always have a synced representation in the Fourier domain, or a triangular waveform always have a sin square type of thing. So, and another catch is here, we are asking about ESD, not actually what is S of f. We are asking about mod of S of f square. So please try to solve this one at least. Check what has been written. Yeah, it is not right. It is none. So basically, let me solve the question. It's not. If you follow the actual representation from the time domain to frequency domain, then it will not be a very time consuming type of effort, because you already know if we have a rectangular pulse with t of bt, then what happens, this has a sync representation, that is sync of pi fbt. So this is the Fourier representation. So this was s of t as per our question, and this is s of f, that is the Fourier transformation corresponding. So later we have asked what is s of f mod square, and this is just doing the mod square type of thing. Basically this is a real quantity, so it is equivalent doing the mod square or only the normal square. So this is also s of f square, if this is, and this is b square t square sec square by dft. Just squaring every term here. So there is a term b square and t square, and none of the it only matches b square and t square, but there is a term b is missing here. In this derivation, so this b is not here, so none of the options are correct. So right option is option is none. Okay. Now let us move to the next question. So question number 6 says, null bandwidth this is bandwidth, okay, null bandwidth of a signal is defined to be the least frequency f0 such that s of f0 s of f0 equal to 0. So I say there is a at least there is a frequency f0 of a spectrum of a signal at which s of f0 is equal to 0. That is a null bandwidth. We define it as follows. And what is s of f? Is the, now just say s of f is the energy spectral density. Now just assume it is not the normal frequency, it is the energy spectral density. It represents energy spectral density. So the task is to find a particular f0 for which we have a rectangular pulse t by 2t, for which s of f0 is equal to 0. So basically the question says we have to find the ESD of that signal, and we have to find at which frequency point the ESD of that signal is equal to 0. So there are 4 options. First option is 1 by t, second option is 1 by 2t, third option is 2 by t, fourth option is none. was saying that but the question is, I think you are thinking because it is a sync pulse, there is no null bandwidth. That is probably is going in your head, but we have defined that S of f0 equal to 0. If it happens even if inside the signal, like if I square this sync pulse, it will be like that sort of thing. So let us derive just it will be clarified. So S of f0, that means equal to 0, at which it is 0. So actually the representation of the signal will be, if I take there will be symptom, right? So basically the signal it was is t by 2t, right? So there will be 2t term also. So the sync will obviously have, it is obviously crossing at somehow like this. And then it is going down. And equally, if we think the energy, it will be more stiff like that. But these negative parts will cancel out slowly. So basically, it crosses the 0 points in these places. And that is the null bandwidth. So the condition is this will be 0, equivalent to 0. And it only happens when, because 2t term, it only happens when sync of pi f0t 2t is equal to 0. Only at this point this happens. At this point this square will also be 0, so ESD will be 0. That is the point. So basically it says that sync should be pi f0 2t. This should be 0. And it will happen when f0 is equal to 1 by 2t. So at 1 by 2t, this value will be 0. I think it is clear for you right now.
Sir, why you have taken sync function?
Because this is a rectangular function, right? At first it
Oh,
is
yes,
a
sir.
function. So
Yes, sir.
if I do the
I
Fourier
didn't.
transformation, it will be a sync function.
Yes, sir. Sync function.
Okay. Let us move to the next question. So next question is, find the autocorrelation yeah, that is Rx t. So what is autocorrelation? Xt x of t plus tau, it's expected. So this only depends on Rx of tau. So basically we represent it like, if I should not say, right, this needs some conditions. Basically it is actually Rx of t. So it says we have a function that is a Gaussian function, you can think 1 by root 2 pi with variance sigma square. I think everybody knows what is the Gaussian is here. Like it is 1 by root 2 pi sigma square and expected value of minus t square by 2 sigma square. Now we said that the sigma square equal to 1. So xt becomes, for our case, it is 1 by root 2 pi into exponential of minus t square by 2. So the point here is the variance of the signal is equal to 1. We just only taken that thing, and obviously the mean is 0. So this type of Gaussian, we say it as normal distribution. So these are just some description, but the question is different from it. The question is, we have the signal xt that is 1 by root 2 pi exponential minus t square by 2, like this sort of signal. And it has a autocorrelation function Rx of t. So we have to comment what is the representation of the autocorrelation function. Option A is 1 by root 2 pi into root pi exponential minus tau square by 4 and option C is none. So again, what is the autocorrelation function? Just let me tell you. I think everybody knows it. It is actually the value Rx that depends on tau is this value. Mostly, if x and x plus t plus tau is a random sort of variable. So another representation, I should not mention it here because this comes in terms of moments, and you will let know I will in the lecture later. So basically, what is the autocorrelation function of that particular function xt that we have defined here, that depends on only t, is r of x of tau is what is x of t and x of t plus tau dt, and it varies. This tau that will, this function t will vary on minus infinite to plus infinite. So solve this one. What is the autocorrelation function? It will obviously vary on this variable tau. That is why we say it is morely Rx of tau. But which one of these will be the right answer? Can I know the answer of question 6? Okay. Question 6 is, the answer of question 6 is 1 by 2t. You guys solve it. Let me write it. So I think nobody has calculated the autocorrelation here. So autocorrelation function Rx of tau, as I described earlier, is taking minus infinite to infinite. So this is x of t root 2 pi and its square, because x of t and x of t plus tau. So x of t has no dependency on t. Sorry, x of t has a dependency of t, but this constant has no dependency on t. So if I multiply x of t into x of t plus tau, it just 1 by 2 pi comes out. So if I simplify this equation, basically x of t into x of t plus tau, it comes like, let me write properly, it will be better, is 1 by 2 pi, because I am multiplying 1 by root 2 pi 2 times into exponential of minus half, this is for x of t, and this is for x of t minus tau, or x of t plus tau. We have declared it as x of t plus tau. So this term comes out here, and here will be another square, and dt. Basically, if I solve this, just you can take this integration and you can solve it. This will be like, just next step I am just solving it, 2 pi exponential minus tau square by 4. This term will come out, and this integration will remain as minus infinite to infinite, because this tau does not depend on 2t. So basically we are taking out this tau, like you can divide it as a square plus 2ab plus b square term, and it will remain as this is 2 into root pi and 1 by root 2 pi exponential minus y square by 2 dy, but y is root 2 t plus tau by 2. We're just replacing this variable here. And if we solve this, it will come like 1 by 2 exponential minus tau square by 4. So I will again suggest you to do this calculation at least once in your hand. So the answer will come like this. It is just doing some integration with keeping in mind the fact that the integration of this function, it is a Gaussian pulse, so minus infinite to infinite 1 by root 2 pi. If you can get this term equal to 1, this is the key catch. As this is a probability distribution, a Gaussian function, if I do an integration from minus infinite to infinite, it will be equal to 1. So that is the catch. So basically this xt is a function of t, but it also represents the Gaussian distribution, normal distribution. So if I do the integration from minus infinite to infinite over xt, it will be 1. So this condition will be used in this equation. So this term becomes 1. That's why we are getting this thing. But from this step to this step, just do the calculation in your hand once. It will be beneficial for you. So the right option is none here. I think it matches 1 by root 2 pi, but 2 root pi. Basically this will be the answer. We have to check 2 root pi. Somehow I think this option matches here. So whatever the matter, this will be the answer. Just check. Okay. Q1 says that EST of a signal is real, and obviously EST of a signal is always real. All the questions will be shared in a text file, like in a PDF file. That link will be shared to you from the NPTEL site. Okay, fine. Now the question says the energy so EF, that is the ESD of a signal, is given as 1 plus F plus F square into exponential of minus F. And the band of the frequency is, that is limited between 0 to F. So we have a signal S of F that is limited to 0 to F and only have the component for F greater than 0 because of this condition. And also the ESD of the signal is given to you. So just a minute. I think this question. There is a confusion about this question, I think. You have to write it. So basically the question says we have a signal that is only limited between the band 0 to F. Okay. So the signal is in between 0 to F and signal has only component for F greater than 0 and the energy function is defined as one plus F square into exponential of minus F, and then is power spectral density type of thing, S of F, and this only can be defined for F greater than 0. And we have to find out what is this S of F here. So basically, if I try to find out this S of F here, this S of F is actually constructs E of F in this way. Right? Because we are doing the integration over this S of F. So basically we are calculating the energy of that signal, and this is the S of F. Over this F, if I integrate over the power, this will somehow give me the total energy of the signal. So from this we can conclude that S of F is nothing but derivation of the signal E of F. And E of F is given by this. So dE of f df will be minus f square plus f into exponential of minus f. So the energy spectral density, that is S of f, it will be this function. Okay. Now let us go to the last question of today. This question says the 95% bandwidth f95 of a signal is defined to be the bandwidth such that 99% of its total energy is contained within this band. So what is the band is minus f95 to f of 95. And the signal is exponential signal. It's for t greater than 0 and 0 elsewhere. So the task is we have to find what is the particular f95. So once more I am repeating the question. It says that we have a exponential signal, exponential of minus sigma t, that obviously varies from 0 to infinite, not that it does not have any non-negative values in the non-negative region of the frequency, or non-negative region of the time, as the signal is exponential. And it says that 95% of the bandwidth, we have to get the particular frequency response of the signal for that region, that is only in the 95% bandwidth of the signal. So that is the question. So it has 95% bandwidth, the signal says, and we have to say what is that bandwidth within which the energy of the signal contains for 95%. So basically, if I interpret this question, this is the exponential signal. It will probably have a frequency domain component, and within this range probably 95% of the energy of that signal contains within this range. So if it is F95, we have to find out what is this F95 for this signal. That is the question. Okay, Shubham, I have a doubt on Fourier transform that x of t s of at, where s of at implies sampling function of Fourier transform of x of t is equal to is correct or not. F of t of if x of t, you think it is the sampling function, and what is a of t? That is the question for me here. It depends on the nature of s of a of t, right? Sampling function, if it is a delta pulse, then uh, a delta pulse has a equal delta pulse representation in the frequency domain, right? So basically, the delta pulse does not change the, like, what should I say? You are taking a x of t is equal to del of t. If this is a sampling, and with some particular time interval, you are just doing this sampling. So basically, this sort of sampling here is happening. So it will just do the repetition of the signal, but you are telling about the fact that you are considering only the sampling function here, right? So if it is a delta pulse, it will also have a del representation in the frequency domain, because del of t will have a equivalent del of f sort of thing. So I don't see any minus t is going to change del of minus f. So this will be, these two things will be equivalent type of thing. Sin t by t for, okay, sin t by t is like, you are not sampling then, right? Sin t by t, or you are going to do it by rectangle pulse, right? Only sin t by t is a sinc function. How you are doing the sampling here? That is the question. Like, uh, the question is, I'm just trying to understand your question. You have this sort of function for sync. It goes like this. That is sin t by t. And how you are going to do sampling with this function? That is my question.
Sir, we can represent the sync by sampling T by pi, na, sir. That way we can represent, na, sir.
Pardon, can you repeat your, like, your voice is not audible.
Uh, Sir, sampling can be written by sync pi multiply by sync of T by pi equal to sampling, na, sir. Multiplying pi and divide by pi. So after that we can convert to
Okay,
rectangle.
I think he has written only sync by t by t. Think so. Basically, I don't think that only sin by t by t is not the sampling function, right? It is some summation included in that term, from minus infinite to plus infinite. Like with a single sync function, you cannot sample the function, right? Like every time there should be another function like this. There should be another function like this. So at every interval here, 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 you just have to sample that particular sort. So this is not only sync by t. This is some summation of syncs from minus infinite to plus infinite. Anyway, if you take a sync function, so that means sync function is always symmetric with respect to its uh, particular. I mean, if you take some sync function for your question, what I understand, if you take a sync function here, so basically this is sort of sync, and you are using sampling for this, so another sync will come like this, another sync will come like this. So just one thing is constant for all of these things, that it is symmetric with respect to this particular axis. So obviously x of t is equal to x of minus t. Sync itself is a even function. So if x of t is equal to x of minus t, I think x of f is equal to x of, their Fourier transform will be same. But I am not clear about what is your question is. I mean, if x of t is equal to x of minus t, then their Fourier transform are also equivalent. Like, you
Sir,
tell me. You
sir, can you
tell me.
give Fourier transform of sync sampling square and sampling so that we can say that f of t f of omega equal to minus omega like that, sir. Can you derive,
No,
sir?
here Subham has written something at 413. That is the question, right? Suppose xt is the sync function here, whatever or sampling function, whatever you are taking. That is correct, right? I'm just asking your opinion. Is it your question? Vishwanathan?
Sir,
I mean, is it your? I'm not getting your question. Like he has written f of t.
I think he will be saying f of omega equal to minus omega like that, sir.
Okay, that f of omega is equal to f of minus omega. That type of thing, right? But see, sync is a real signal, so its frequency domain thing will also be even. That is the conclusion from my side. Sync is a real signal, right? So
Yes, sir. Yes, sir.
its frequency domain representation will be even function.
Yes, sir. With our duality, that a naught pi by k, I have some doubt in that, sir. That's why I'm asking.
So
We actually for a naught sampling kt, the function is from minus k to k. A naught pi by k is the magnitude of area of magnitude of rectangle. I am asking that, sir.
can you please type your actual question? I'm not getting your voice properly, so it will be better if you type in the chat box at least once.
Sir, why don't you please complete question number 9?
Yeah. So yes, Vishwanathan, you can write it in the chat box, and I will just do that. So So Fourier transform here x of f just is minus infinite to infinite for exponential minus sigma t into exponential of minus 2 pi j ft dt. So this is over 0 to t tends to infinite. So this indication limit comes to 0 to infinite only. And if I do the calculation, it will come like 1 by sigma plus 2 pi jf. So the power spectral energy spectral density type of thing will be 1 by sigma square plus 4 pi square f square. Why? Because it is x of f. So x of star f will be 1 by sigma minus 2 pi jf. So just multiply x star of f with x of f and you will get s of f. This is x of f, sorry, x of f, x star of f. This is equivalent to s of f and you will get this value. So the question says at particular which region the most of the energy are conserved. So we have to calculate E of f first. This says what is the actual energy content in which region. So suppose it is from minus f to f. We have to calculate what is the energy content from minus f to f in terms of the frequency. So if we calculate df dash sigma square plus 4 pi square f dash. So this is the famous formula of integration for tan inverse. So we do the integration here with respect to df dash. This comes pi sigma to tan inverse 2 pi f by sigma. Now the definition says that we have to calculate 95 for which region, and from this equation we can say that if limit of f tends to infinite, energy is equal to 1 by 2 sigma. From this equation, substituting the value of f. So E of f95 will be just by 2 sigma, or f95 would be sigma by 2 pi tan of 0.95 pi by, from the equation that E of f is equal to 1 by pi sigma tan inverse 2 pi f by sigma, substituting that fact. And if I calculate this, this the region of the frequency for which 95% of the energy is constituted. I think it is clear for everyone. Is Vishwanathan, it is you are saying that you are multiplying the sampling function with a constant a and sampling squares function with that both of them will give you the same type of result, like only the sync it will be sync squared there, or a is a like take this function. A say it will be a sync function and a this is square of t, it will be a sync square function.
Sir, it is Fourier transform of sampling is rectangle, and the Fourier example of Fourier transform of sampling
This is
square is a
rectangular
triangle.
this is rectangular, right? Or this is also
Sir,
same.
that is sin t by t, no, sir.
Okay, this one is sin t of t, so this will be rectangular.
My question is about the that area of a rectangle, sir. That's where I am facing problems.
Okay, if it is from minus infinite to infinite, then there will be also minus infinite to infinite.
Yes, no, sir. That will be from minus 1 to 1. And the amplitude of that's where I'm.
How are you saying that? That is my question. You are doing essay of t, and with some, if you are taking a sampling through sync, right? Ask my question. I hope you remember. So basically, you are doing a time shifting of that sync, right?
Sir, no, sir. We are not doing time shifting. We use only Fourier transform, sir. E power j omega minus j omega
That
t
is my that
into sampling.
okay, that I agree, but you are doing the sampling with a sync pulse, right? And this sync pulse is from minus infinite to plus infinite summation. You have to take at every this instant you have to take a sampling, right? That is your fundamental thing. Otherwise, how you are doing the sampling? At every peak of the sinks, you are doing the sampling, right? What does the sampling means? You have an analog signal. You are just sampling at particular frequency. So you cannot generate delta pulses. Instead of that, you are generating sync pulses, and you are taking the value of the sync pulse. What happens at the peak? Another sync pulse here at the peak. What happens the value? That is sampling, right?
Sir, this sampling function that converts from analog to digital. I'm not talking about that, sir. Fourier transform of this one, sir. This I am understanding, sir. That quantization error, that is not function, sir. That sampling I am not talking, sir. But sin t by t Fourier transform.
Sin t by t Fourier transform is rectangular.
Yes, sir. That's amplitude I'm asking.
Okay, that you have to use the duality property. Sin t of t. So basically, in question number
Sir,
6.
this one, please. This is,
Uh-huh.
please do this, sir. Kindly. I'm having doubts. Sorry, sir.
Oh, for sin t by t, right?
Sin t by t and sin uh, sampling 2t ka square, kt ka square.
This function. Sorry.
Yes, sir.
This one, sir.
We that is scaled by k, sir.
Whatever constant it will be remain there.
Sir, that is that is for that time period. See, that is not outside, sir. Inside the time function, like scaling time property. Sir. That one.
Okay. This two is your question, right?
Yes, sir. Exactly, sir. Yes, sir.
Just let me note it down.
ఇలా
ఇదిగో ఎందరు పెట్టడానికి
Okay, fine. I will give you the particular. I will do the derivations 1 second for your clarity. 1 second, and I will let you know in the next class. Okay, is it fine?
Okay, sir. Okay, sir.
So anybody has
Thank you, sir.
okay. So I think everything is fine for today's class. Anybody has any doubt? Extra doubt? Okay. We'll meet in the next Sunday.